Okay, final problem. Number 9. Show the steps of the Fermat factorization algorithm for n equals 2093. So the Fermat factorization algorithm is a method for finding factors of a number. It will always work eventually, but it works better for composite numbers whose factors are close together, i.e. close to the square root of n. Now, I was a little cheeky with this one. I chose an n that takes, a little bit of work, just so you can have extra practice with the algorithm. So the first step is we're going to calculate the ceiling of the square root of n. So ceiling just says round up if I don't have an integer. Square root of 2093, I get 45 and change, so the ceiling of that number is 46. And I ask myself, is 46 squared minus 2093 a perfect square? And I say, no, that number is 23. And again, I can just check that real quick. 46 squared minus 2093 is 23, which is not a perfect square. Since this is not a perfect square, I'm going to add 1 to this number here. And I ask, is 47 squared minus 2093 a square number? No, that one is 116. Is 48 squared minus 2093 a square number? No, it is 211. So after 11 steps, there's only so much I can put on this slide. After 11 steps, I get to asking, is 57 squared minus 2093 a square number? Yes, that number is 1156, which is equal to 34 squared. Okay, cool. We are done with the iteration. How do I use this information that I've got to find factors of 2093? I know now that 57 squared minus 2093 is equal to 34 squared. So I will rearrange the equation and say that 2093 is equal to 57 squared minus 34 squared. Now that I have the equation written this way, here I have the difference of two perfect squares. No matter what they are, this expression will factor. Here I get 57 minus 34 times 57 plus 34. So whatever these say, this is x squared and y squared. Difference by squares factorization says that I will get x minus y times x plus y every single time. It's a really cool algebra trick. So what is 57 minus 34? That's 23. What is 57 plus 34? That is 91. So 23 times 91 must give me 2093. And I am done.